We think we understand where danger lives, near the surface, in clear water, in the shape of a fin cutting through light. But the ocean is not a ceiling of blue, it is a descent, beyond the glare of the sun, beyond the reach of warm currents. The sea folds into layers that most life never touches. Nearly 90% of the ocean lies deeper than most sharks ever swim. Light thins, color drains away, temperature falls, pressure rises with a steady, invisible hand. At 200 meters, the last trace of daylight dissolves, and photosynthesis ends. Below 1,000 meters, the weight of the ocean presses more than 100 times harder than at the surface, increasing with every descent of 10 meters. Most well-known sharks remain above this boundary, built for vision, speed, and open water sustained by surface life. And yet, this is where most of the ocean exists. Entire ecosystems drift in darkness where no plant has ever seen light. The deepest waters are colder than Antarctica and darker than space. Food becomes scarce. Some species go decades without encountering another of their kind. We have mapped more of Mars than we have of our own deep seabed. Bodies begin to change. Some fish grow teeth longer than their own heads. Some produce their own light in permanent darkness, including rare predators that emit red light most creatures cannot see. Others swallow prey larger than themselves, their stomachs stretching to survive uncertainty. Some forms appear almost unchanged from fossils hundreds of millions of years old. Certain predators do not chase, they wait, sometimes with a faint lure extending from the body itself, patience replacing speed. Some endure pressures that would crush steel. There are sharks in the deep, but they are not the most unsettling presence. The deeper we descend, the less familiar survival becomes. Evolution stretches, rules loosen, familiar instincts fade. We think fear has a shape, but the shark zone is only the beginning. But if sharks are apex predators, why does almost the entire ocean lie far below where they swim? What happens to life when light disappears and food becomes scarce? How do bodies adapt to pressures that would collapse anything built for the surface? And what kind of predator evolves when speed no longer matters? Tonight, we are traveling downward through the layers of the sea, watching evolution loosen the rules we thought it followed. But before we begin, if you enjoy these calm explorations into the deep sea, I would appreciate it if you gave this video a like, and perhaps tap subscribe. It helps other curious dreamers find their way to this peaceful little corner of the internet. And if you'd be so kind, let me know in the comments, where are you listening from tonight, and what time is it where you are? It's always a joy to see how far across the world this little sleepy corner of science travels. Now take a slow, deep breath, let your shoulders soften, and together let us drift gently toward the creatures that wait beyond the shark zone. Above the continental shelves and drifting plains of open water, sunlight does more than illuminate. It structures a living ceiling where movement, color, and perception weave together into a bright lattice of survival. Here, illumination is not merely a condition, but a currency, traded between hunter and hunted in flashes of silver scales and shifting silhouettes. In this radiant band between 0 and 200 meters, most familiar sharks glide with quiet authority, their forms shaped by a world where sight guides nearly every decision. Their eyes, adapted for contrast and motion, read the water the way birds read wind. A slight flicker reveals a school turning in unison. A faint outline betrays distance. Vision allows pursuit to unfold as a measured calculation rather than chance. Muscles built for swift acceleration answer instantly, propelling streamlined bodies through open space where there is room to chase and time to correct course. The architecture of these hunters reflects the physics of their realm. Long pectoral fins stabilize lift, tapered snouts divide the current. Every contour belongs to a design meant for clear water filled with light. The abundance surrounding them sustains this elegance. Near the surface, microscopic algae drift in vast numbers, converting sunlight into living matter that nourishes swarms of plankton, which in turn sustain fish, which then sustain predators. Energy cascades upward in layered exchanges, and large hunters thrive where this chain remains unbroken. A shark moving through these waters carries within its muscles the stored sunlight of countless unseen organisms, each link quietly supporting the next. Temperature also shapes this boundary. The upper ocean holds warmth gathered from the sun, a steady reservoir that keeps metabolism efficient and muscles responsive. Most sharks depend on this thermal stability. Their bodies are designed to function within a narrow range, and as water cools with depth, chemical reactions slow, reflexes soften, and endurance fades. Only a few species possess specialized systems that conserve internal heat, and even they seldom wander far from layers where warmth still lingers. Beneath this bright expanse, conditions shift in ways that challenge such finely tuned forms. Eyes adapted for brightness lose their advantage. Speed offers little benefit where prey is sparse and scattered. The very traits that define these hunters become costly ornaments when energy must be guarded rather than spent. So they remain where their design belongs, tracing silent paths through the illuminated currents, while below them the water deepens in hue, and the familiar blue gradually yields to a dimmer shade that welcomes different kinds of life. Oceanographers chart the sea, the way astronomers chart the sky, not as a single expanse, but as stacked realms, each defined by its own quiet laws. These vertical provinces descend in measured tiers, known as the sunlight zone, the twilight zone, the midnight zone, the abyss, and the trenches. Boundaries between them are invisible, yet life recognizes each threshold with precision, as though crossing unseen borders drawn in pressure and chemistry rather than ink. In the highest band, illumination still filters down from above, thinning gradually until near 200 meters, it fades into a dim cobalt hush and then slips away entirely. With its departure, a fundamental transformation settles in. Photosynthesis ceases, and with it the steady creation of new nourishment. No drifting plant cells weave sugars from radiance. No blooms arise to feed clouds of grazers. The great engine that powers most ecosystems slows, then stills. What remains must endure on fragments that sink from far above, a slow snowfall of organic remnants descending through the water column. As depth increases, weight gathers with patient consistency. Every 10 meters adds another atmosphere of force, pressing from all directions at once. By 1,000 meters, the surrounding mass bears down with a burden equal to hundreds of meters of stone. Such pressure alters the very architecture of living tissue. Proteins must fold without collapsing. Cell membranes must remain flexible without leaking. Gases that would expand near the surface compress into near invisibility. Creatures native to these levels carry molecular designs that resist distortion, subtle biochemical adjustments refined across generations beyond counting. Large hunters of the upper layers seldom cross into these deeper provinces. Their bodies, tuned for speed and distance, demand frequent meals and efficient oxygen use. In the depths, prey is dispersed and encounters are rare. A swift chase would spend more energy than it could recover. Muscles suited for bursts of motion become costly to maintain, and buoyancy systems built for lighter conditions struggle under the increasing load. The descent asks for a different arithmetic of survival, one that favors restraint over pursuit and endurance over strength. Downward still, The water thickens into a darkness so complete that day and night lose meaning. Here the midnight zone yields to the abyss, and the abyss slopes toward trenches that cut into the crust itself. Each step lower reduces warmth, slows metabolism, and lengthens the intervals between meals. Life persists, though in altered forms, shaped by scarcity into patience and by pressure into resilience. Above, the swift silhouettes gradually thin and vanish into the distance, their domain ending where the deep begins to assert its older rules, and in that quiet turning, evolution follows a different current. Far below the wandering currents, a single point of light drifts, as though a star has forgotten the sky and settled into water. It sways gently, unhurried, suspended from a slender filament that grows from living flesh. The glow is not reflection, but creation, a quiet chemical lantern kindled within a small chamber at the tip. In that silent distance, the light pulses faintly, patient as a heartbeat, offering a signal that promises something nearby. The body that carries it remains almost motionless. Fins barely stir. Muscles conserve themselves. This creature does not roam in search of opportunity, because opportunity in this realm seldom appears twice. Instead, it waits, trusting stillness more than motion. Its silhouette is soft and dark, shaped less for travel than for suspension, as though the water itself were a cradle. At the front rests a mouth that seems too large for the rest of the form, a crescent lined with slender teeth curved inward like delicate hooks. They do not tear or slice. They hold. Once something passes between them, retreat becomes impossible, the shape of each tooth guiding prey deeper rather than outward. The jaws open wider than the head appears capable of allowing, ligaments stretching with careful elasticity, skin unfolding without strain. Within, the stomach can swell far beyond its resting size, expanding slowly to contain whatever fortune arrives. Meals may be separated by long spans of drifting time, so the body accepts abundance whenever it comes. Among these beings, size tells a quiet story of devotion. The female grows many times larger than the male, her form broad enough to carry both lure and future. The male begins life small and solitary, guided by scent through immense distances until he finds her. When he does not leave. His jaws fasten gently into her skin, and over time, his tissues merge with hers, their circulatory systems joining until he becomes a permanent extension of her body. He receives nourishment from her blood, and in return provides what she needs to produce young. Two lives settle into one continuous existence, a union so complete that his eyes and fins eventually fade, no longer required. In such depths, swiftness offers little reward. Motion spends energy, and energy is a treasure rarely replaced. So this hunter trades pursuit for presence, letting the small lamp above its head speak on its behalf. The glow wavers softly in the dark water, an invitation written in light, while the mouth below waits with infinite calm, certain that in time, something curious will draw near. Color abandons the ocean in a precise order, as though the spectrum itself were slowly exhaling. Reds fade first, vanishing within the upper descent until only blues remain to wander downward. By the time the deeper layers settle into their perpetual dusk, scarlet has long since disappeared from ordinary sight, leaving most inhabitants of these regions unable to perceive it at all. In this quiet absence, one hunter carries its own hidden shade. The dragonfish moves with a narrow, ribbon-like grace, its body elongated and dark as polished obsidian. Along its sides rest small organs that kindle faint glows, each one a controlled chemical ember. Among these lights is one unlike the others, a beam of deep crimson produced through specialized pigments and luminous molecules working together in delicate reaction. To human eyes, it would appear dim yet unmistakably red, but to nearby creatures, it is nothing at all, a wavelength beyond their visual reach. The illumination touches them without announcing itself, bathing their forms in a color they cannot detect. Its eyes are shaped for this private radiance. Large pupils gather the slightest trace of brightness, while retinal tissues hold pigments tuned to wavelengths that most deep dwellers never evolved to notice. Within those dark spheres, the dragonfish perceives a secret landscape revealed only to itself. A drifting crustacean, a small fish hovering in stillness, each becomes visible when the hidden beam passes over them. The hunter does not rush. It glides with restrained movements, letting its unseen lantern search the water ahead. The mouth beneath those watchful eyes holds teeth so slender they resemble glass needles. They angle inward, fine and numerous, forming a lattice that closes without gaps. When the jaws part, they open farther than expected, the hinges allowing a wide arc that can surround prey before it senses the approach. The body remains slim, built not for bursts of pursuit, but for precise positioning. In a realm where meals are uncertain, accuracy matters more than speed, and silence is more valuable than force. Other animals drift through these depths, guided by faint glimmers or gentle currents, unaware of the scarlet beam tracing their outlines. The dragonfish advances through that private glow as if walking through its own narrow corridor of vision, each movement measured, each pause deliberate. Its metabolism runs slowly, conserving fuel, its muscles composed of fibers suited for steady motion rather than sudden effort. Even its bones are lightly formed, reducing the cost of simply existing in a place where every calorie must justify itself. So it travels through the dark with a color no neighbor can see, a quiet radiance carried like a secret thought, and in that concealed light, the hunter reads the shapes of the living world around it, moving forward with unhurried certainty. Long before modern coastlines settled into their present shapes, before whales traced their first paths through open water, a lineage of sharks already moved through ancient seas. Their forms passed quietly from epoch to epoch, leaving impressions in stone that would one day rest in museum drawers, thin skeleton outlines pressed into shale like memories the planet chose to keep. Among those enduring designs is a hunter whose living shape still resembles those fossil imprints, as though time brushed past it without insistence. The goblin shark drifts through deep water with a posture that seems almost deliberate in its strangeness. Its skin carries a pale rose tint, not from pigment but from circulation itself, the fine network of blood vessels visible beneath a translucent surface. Without heavy coloration to shield it, the body appears softly luminous in its own muted way, a quiet reminder that flesh can reveal what it usually conceals. This delicate exterior sheaths a structure older than many mountain ranges, a blueprint refined across more than 100 million years of shifting oceans. Its most remarkable feature rests folded beneath the head. The jaws do not remain fixed in place like those of most fish. Instead, they rest on specialized ligaments and cartilage that function like guided rails. When prey drifts within reach, the entire jaw assembly extends outward in a swift projection, sliding forward from the skull with precise mechanical certainty. Teeth arranged along the edges stand slender and sharp, suited for gripping rather than cutting. The motion is brief, almost gentle in appearance, yet it closes distance faster than a body could swim. Once the jaws return, they carry the captured animal inward, and the hunter resumes its slow passage as though nothing unusual occurred. Sight is limited where this species travels, yet its senses remain attuned to faint signals carried through the water. Receptors along the snout detect subtle electrical pulses released by muscle contractions in nearby creatures. Even the smallest movement produces a field, and the goblin shark reads these invisible patterns the way surface animals read tracks on soil. Guided by such currents, it navigates expanses seldom visited by its relatives, descending into regions where familiar silhouettes no longer accompany it. Encounters with living individuals are rare, not because the species is scarce, but because its home lies far below common paths. Most observations come from deep nets or remote instruments, brief meetings that offer only a glimpse before the animal slips once more into obscurity. There, it continues its unhurried existence, carrying an ancient design through modern waters, a quiet survivor from eras that vanished long before the first human breath stirred the air above. In a realm where nourishment drifts only rarely, the architecture of a predator can become a quiet record of hunger's long influence. The fangtooth carries such a record upon its face. Its body remains modest in size, compact and dark, yet its teeth rise in pale arcs, so large they seem borrowed from a far bigger creature. Each one curves like polished ivory, smooth and narrow, extending past the line of the jaws when the mouth is closed. In proportion to its length, no other ocean dweller bears such extravagant armament. These teeth do not exist for display or rivalry. They are instruments shaped by generations that could not afford missed chances. When food appears only after long intervals, the first grasp must also be the final one. The fangtooth's jaws hinge wide, opening farther than its skull suggests possible, and within the upper palate lie small recesses, delicate sockets where the lower fangs rest when the mouth shuts. Without these spaces, the jaws could never close, for the teeth would block their own motion. Instead, they fold together with precise alignment, each point sliding into its designated groove as neatly as keys settling into a case. The rest of the animal seems almost understated beside this elaborate dental array. Its scales are small and rough, its fins short, its muscles suited for measured strokes rather than bursts of pursuit. It moves through deep water with a steady, deliberate rhythm, conserving strength. Large eyes watch for passing silhouettes, gathering faint traces of brightness that filter down from distant layers. The senses remain attentive, yet nothing in its motion suggests urgency. Time behaves differently in such depths, stretching wide between encounters. Within that patient span, the teeth wait. They are thin enough to pierce with little resistance, sharp enough to hold even the most slippery form. Once closed, the jaws create a living cage from which escape is nearly impossible. Prey may be small or nearly equal in size to the hunter itself, yet the fangtooth can manage either, its gape and dentition prepared for whatever fortune brings. Energy spent on growing such formidable tools is considerable, but the return lies in certainty. A single successful capture can sustain it through long periods of drifting quiet. It lives farther down than many hunters dare to travel, in regions where pressure weighs steadily and resources arrive without schedule. Few observers have witnessed it in its native surroundings. Most glimpses come when deep trawls briefly lift one toward unfamiliar brightness, its teeth gleaming softly before it vanishes again below. There, in the dim stillness that shaped it, the fangtooth continues its unhurried patrol, a small figure carrying an oversized inheritance, each curved blade a testament to the slow arithmetic of survival. There are forms in the deep that seem assembled from gestures rather than solid lines, as though the sea shaped them while half dreaming. The gulper eel drifts in this manner, its outline loose and unhurried, a slender ribbon of dark tissue tapering into a tail so fine it resembles a trailing thread. Nothing about its posture suggests urgency. It hangs in the water with a patient stillness, sustained by a body composed mostly of soft material instead of dense muscle or heavy bone. At first glance, the head appears small, almost delicate, yet this impression dissolves the moment its jaws begin to open. The mouth unfolds gradually, stretching outward and downward until it forms a vast oval frame that dwarfs the rest of the animal. Hinges at the skull allow this expansion, and the skin between the lower jaws spreads like thin fabric drawn taut. The structure is not rigid but flexible, supported by cartilage that bends without breaking. When fully extended, the gape becomes large enough to envelop prey nearly its own size, an astonishing proportion for such a narrow creature. Inside, the throat continues the transformation. It widens into a pouch capable of swelling as food enters, accommodating whatever has been captured. This ability is essential where meals arrive unpredictably. The eel does not chase with speed or wrestle with strength. Instead, it drifts until something edible passes within reach, then opens its immense net of a mouth and draws the animal in with a sudden intake of water. Once closed, the jaws contract slowly, guiding the prize inward, while excess water escapes through the gill openings. The motion is economical, each movement measured to preserve precious energy. Trailing behind, the tail extends into a delicate filament tipped with a faint point of light. The glow is subtle, produced by specialized cells that release a soft luminescence. It wavers gently as the eel hovers, a small beacon suspended at the end of a living line. Creatures attracted to that distant shimmer may approach without noticing the dark shape attached to it, and in that quiet approach, the eel gains its opportunity. Its entire anatomy reflects the arithmetic of scarcity. Muscles remain thin, bones reduced, organs arranged with space between them, all lessening the cost of simply existing. Even the skin feels gelatinous to the touch, an adaptation that allows neutral buoyancy without constant effort. In this way, the gulper eel spends little while it waits, and waiting is the rhythm that defines its life. So it lingers in the vast water, mouth folded once more into modest size, tail light wavering like a distant star seen through mist, the whole creature adrift yet prepared, a patient silhouette shaped by the long intervals between chances. In certain midwater regions, the sea grows so depleted of oxygen that most gilled creatures cannot remain there for long. These layers form vast horizontal bands where respiration slows and movement becomes costly, as though the water itself were gently withholding breath. Yet within these quiet expanses lives a small cephalopod whose existence unfolds at a pace suited perfectly to such scarcity. The vampire squid drifts here, neither hurried nor strained, sustained by a metabolism so restrained it can endure conditions that would exhaust more active animals. Its body is soft and dark, shaped like a delicate cloak, gathered at the top and trailing below. Thin filaments extend from within its arms, finer than threads, capable of sensing subtle disturbances in the surrounding water. Rather than pursuing prey, it gathers fragments of organic material that settle through the depths, drifting particles sometimes called marine snow. These specks may be bits of plankton, flakes of distant remains, or minute debris bound together by mucus. The squid collects them patiently, drawing them toward its mouth with careful motions, each fragment accepted as nourishment. When disturbed, its response is unlike that of its shallow water relatives. Instead of releasing a cloud of ink, it produces a luminous secretion from the tips of its arms. The substance emerges as a scattering of glowing droplets, each one shining softly as it disperses. Suspended in the water, the particles form a curtain of light that lingers for precious moments. While this gentle constellation hangs behind, the squid folds its arms upward and inward, turning its body into a rounded silhouette. The webbing between the limbs stretches across the surface, enclosing the form like a cloak drawn tight, concealing the softer underside from view. This curling motion gives the impression of reversal, as though the animal has turned itself inside out, though in truth it has simply rearranged its posture with elegant efficiency. Spines along the arms angle outward during this display, presenting a quiet barrier while the creature drifts away. Every movement is deliberate and economical, shaped by the demands of a place where oxygen is sparse and energy must be spent with care. Inside its tissues, specialized proteins bind oxygen more effectively than those of many other cephalopods, allowing each molecule to be used thoroughly before release. Its blood carries a faint bluish tone from copper-based hemocyanin, a respiratory pigment well suited to low concentrations. Even its muscles contain fewer fibers, reducing the demand for oxygen at rest. These refinements permit a life lived in stillness, where survival depends not on force or speed, but on balance. So, the vampire squid remains suspended in its dim province, gathering what drifts, glowing briefly when pressed, and settling again into silence, a small keeper of calm in waters where breath itself is rare. Transparency is a rare decision in the architecture of animals, yet in the deep it appears again and again, as though concealment sometimes chooses clarity instead of shadow. The barreleye fish carries this idea further than almost any other vertebrate. The top of its head forms a smooth dome, clear as polished glass, a living window through which its inner structures can be seen. Beneath that curved shield rest the organs that guide its perception, visible and unhidden, suspended like instruments inside a delicate observatory. Within this Prasrachan chamber lie the eyes, shaped not like spheres but like elongated tubes set side by side. Their greenish lenses point upward most of the time, aligned toward the faint brightness filtering from distant layers. In that direction, silhouettes pass now and then, soft outlines of drifting animals or falling fragments. The fish watches these shapes from below, holding its position with minute adjustments of its fins, its gaze fixed through the ceiling of its own skull. Pigments within the eyes filter stray wavelengths, sharpening contrast so that even slight movements above become clear against the dim background. When necessary, the eyes can rotate within their transparent housing. Muscles shift them forward, allowing the fish to look straight ahead instead of upward. This motion happens slowly, almost thoughtfully, as if the animal were turning lenses rather than moving organs of flesh. Such flexibility grants it two modes of awareness, one scanning the distant overhead, the other examining what lies before its narrow mouth. The dome remains still while the eyes glide inside, preserving the smooth outer surface without distortion. The body attached to this remarkable head is slender and fragile, composed of soft tissues that bruise easily if brought into rougher currents. Bones are light, muscles fine, every part arranged with restraint. Strength is not its strategy. It feeds on small drifting creatures and gelatinous animals, items that require precision rather than force. Its mouth is small but exact, suited for delicate capture. Even the fins appear understated, thin fans that maintain balance rather than speed. Such refinement comes with vulnerability. The fish cannot tolerate sudden pressure changes, and rarely survives encounters with nets that draw it upward. For this reason, it remained unknown for many years, except as damaged specimens, its true posture and living colors hidden until quiet observation became possible in its native depth. There it continues its gentle watch, suspended beneath the distant glow it studies through its crystal canopy, eyes turning slowly in their lucid chamber, while the rest of the body waits in patient stillness. Motion in the deeper reaches of the ocean becomes something carefully measured, almost rationed, like breath in thin air. Bodies that descend into these levels gradually abandon the restless patterns common above, trading urgency for restraint. Here, movement itself carries a cost that cannot easily be repaid. Muscles require fuel, and fuel arrives rarely, so each flick of a fin must justify its expense. Predators, shaped by this arithmetic, do not pursue in long chases. A rapid surge through the water would burn more energy than a single meal could restore, especially when encounters with prey may be separated by long intervals. Instead, hunters settle into stillness and allow the environment to bring opportunity toward them. Currents drift, particles fall, small creatures wander. Patience becomes a strategy as tangible as teeth or claws. The animal that waits often fares better than the one that searches. This shift influences every detail of anatomy. Fins grow broader or more delicate, suited for hovering rather than sprinting. Muscles develop fewer fast-twitch fibers and more slow ones, capable of sustaining gentle motion for extended periods without fatigue. Even the chemistry inside the cells adjusts. Enzymes operate efficiently at low temperatures, and metabolic reactions proceed at unhurried rates, conserving precious reserves. The heart beats more slowly. Respiration follows suit. Life continues, yet at a tempo stretched far beyond that of surface waters. Ambush replaces pursuit as the dominant design. A predator may remain nearly motionless, aligned with the faint flow of water so that it drifts rather than swims. Sensory systems stay alert while the body rests. When a passing animal strays close enough, the strike is brief and precise, lasting only an instant before stillness returns. Such moments are rare but decisive. Success depends not on stamina, but on timing. The scarcity of nourishment reinforces this pattern. In regions where organic matter arrives only as scattered fragments or infrequent visitors, every calorie must be guarded. Many inhabitants possess tissues that require little maintenance, gelatinous structures, or lightly mineralized bones that reduce the energy needed simply to exist. Some species can endure long spans without feeding at all, their bodies sustained by reserves accumulated during earlier fortune. Growth proceeds slowly, reproduction even more so, each process unfolding across extended seasons of darkness. Seen together, these adaptations create a realm where haste has little purpose. Life does not vanish here, nor does it struggle in frantic motion. Instead, it settles into a quieter rhythm, guided by efficiency rather than speed. Fins stir once, then rest. A body glides, then pauses. In this measured world, survival belongs to those that spend almost nothing, and in that gentle economy, time itself seems to lengthen, stretching calmly through the water like an endless tide. Weight gathers in the ocean without sound or motion, increasing with depth as steadily as falling sand in an hourglass. Nothing announces its presence, yet every descending meter adds another layer of force that presses evenly from all sides. In these lower regions, the burden becomes immense, not as a sudden crush, but as a constant embrace that never loosens. Creatures who belong here do not resist it. They are shaped to accept it completely. Within their cells, delicate structures must continue to function while surrounded by this compression. Proteins, those intricate molecular machines folded into precise forms, would normally warp under such strain. In deep-dwelling species, however, their chemistry has been subtly altered. Certain compounds stabilize the folds, allowing them to keep their shape and continue their work. These molecules, known among biologists as piezolites, drift within the cellular fluid and act like microscopic supports, preventing distortion. Enzymes remain active, membranes remain intact, and life proceeds even where pressure would disable ordinary tissue. Skeletons also reflect this quiet accommodation. Instead of heavy mineral frameworks, many inhabitants possess bones that are thin, flexible, or partially reduced. Some rely more on cartilage than calcified material, allowing their bodies to yield slightly rather than fracture. Flexibility becomes a form of strength. When force surrounds an organism equally, rigidity can become a liability, while gentle resilience allows the shape to hold without breaking. Muscles attach to these lighter structures and move them with minimal effort, maintaining posture without unnecessary strain. Gases present a different challenge. Near the surface, air pockets can help with buoyancy or breathing, yet at great depth, such spaces become dangerous. Compression shrinks them rapidly, collapsing chambers that cannot equalize. For this reason, many deep-living animals lack internal cavities filled with gas. Swim bladders, lungs, or other air spaces are reduced or absent, replaced by tissues and fluids that do not compress in the same way. Even microscopic bubbles within the body can cause harm if they contract too quickly, so the physiology of these creatures avoids them entirely. Circulation and chemistry adjust in harmony with these structural changes. Blood carries oxygen efficiently despite the surrounding force, and cell membranes contain lipids arranged to remain fluid rather than stiff. Each adaptation is subtle on its own, yet together they form a complete design suited to an environment defined not by temperature or light, but by pressure itself. In this unseen embrace, life continues without strain or struggle, held gently within the immense weight of water, every organism shaped to match the force that surrounds it, as though the ocean had pressed its signature into their very substance. Darkness in the deep ocean is not empty of expression. It speaks in brief glimmers, in pulses that appear and vanish, in soft radiance shaped by living chemistry. This illumination does not come from above or afar. It is written directly into the bodies of the inhabitants themselves, produced through reactions in which specialized molecules release photons as calmly as breath leaving lungs. Within tiny organs called photophores, enzymes guide these reactions with delicate precision, allowing creatures to shine without heat or flame. Each species forms its own dialect of light. Some release steady halos that outline their shapes, while others send patterned flashes that ripple along their sides. A few produce sudden bursts, bright enough to startle nearby animals, then return to obscurity as quickly as they appeared. These signals move through the water like silent syllables, visible across distances where scent and sound would fade. In a realm where color is scarce and forms are difficult to distinguish, such glows become a primary language. Many fish use this living radiance not to reveal themselves but to disappear. Their undersides carry rows of faint lights matched carefully to the dim glow filtering from far above. By adjusting the brightness, they erase their silhouettes when seen from below, blending seamlessly into the distant shimmer. This strategy, known among researchers as counter-illumination, turns the body into a mirror of its surroundings. Predators looking upward find no outline to follow, only a continuation of the faint luminance beyond. Elsewhere, light becomes an instrument of invitation. Small, luminous tips or dangling filaments sway gently, resembling drifting morsels. Creatures drawn toward these signals approach without sensing danger, guided by the promise of food or companionship. The glow does not chase them. It waits, steady and convincing, until curiosity brings them close enough for capture. In such encounters, illumination serves as both message and mechanism, a visible whisper that conceals its intent. Communication also unfolds through these radiant gestures. Brief sequences of flashes can signal readiness to mate, warn rivals, or coordinate movement within a group. The timing, intensity, and rhythm carry meaning, as distinct as calls in a forest canopy. Some species answer one another in measured intervals, exchanging pulses that confirm identity before drawing nearer. Others release waves of light that travel across a gathering like a passing thought, linking individuals who may never touch. Across these depths, bioluminescence threads through daily existence, not as spectacle, but as conversation. It marks territory, guides encounters, conceals outlines, and shapes destinies. Countless organisms carry this quiet vocabulary within them, each glow a word, each flicker a phrase, until the unseen water becomes filled with messages written in living light. Sailors once spoke of vast shapes moving beneath their vessels, forms too large to measure and too silent to confirm. For generations, such accounts drifted between myth and memory, carried across harbors in low voices. Only much later did evidence rise from the deep to show that one of these whispered beings was real, a cephalopod whose existence had unfolded far below ordinary sight long before anyone gave it a name. The giant squid lives in regions seldom visited by light, its body long and supple, its arms lined with pale suckers that hold with gentle firmness. At the front of its head rest eyes of astonishing scale, each one broad as a dinner plate, designed to gather the faintest trace of illumination. These immense organs do not seek detail so much as presence. In water where visibility is limited, the ability to notice a distant shadow or a shifting outline can mean the difference between safety and encounter. The lenses curve smoothly, and within them, sensitive tissues register even subtle changes in brightness, allowing the animal to perceive movement from far away. Its life remains mostly hidden, yet fragments of its story have surfaced through quiet clues. Whales that dive to great depths sometimes bear circular scars upon their skin, impressions left by rows of suction cups. These marks tell of meetings in darkness where two ancient hunters cross paths. The squid does not pursue such giants, yet when confronted, it can resist with surprising strength, arms extending, suckers fastening, each contact leaving its temporary seal. The whale, in turn, may grasp its elusive prey, and in that silent contest both creatures depart marked by the encounter. Rarely, individuals rise toward upper waters, perhaps weakened or disoriented, and are glimpsed by human eyes for the briefest moment. Such sightings are fleeting, often at night or during storms, when the sea surface churns and vision blurs. A pale form appears, tentacles trailing, then slips away again before certainty can settle. For centuries, these brief encounters formed the only evidence, too scattered to assemble into a clear picture. Without living observation, the animal lingered in imagination, its proportions exaggerated, its habits invented, its presence questioned. Only with patient study and distant cameras lowered into its domain did the outlines grow clearer. There, in the quiet depths where it belongs, the giant squid moves with measured grace, neither hurried nor still, its great eyes open to the dim surroundings. Its long tentacles extend and retract with fluid ease, tasting currents, sensing vibrations, gathering what the water offers. The legends that once surrounded it now rest gently beside the truth, both shaped by the same enduring mystery that drifts through the deep. Far to the south, beneath waters that circle Antarctica in slow and powerful currents, another cephalopod moves through the cold dark, built not with the length of drifting ribbons, but with the density of something forged for strength. The colossal squid inhabits this remote region, where the sea holds a chill that steadies every motion. Its body is thick and muscular, compact compared with its longer relatives, yet carrying greater weight within that shorter frame. Mass rather than length defines it, as though the animal gathered its substance inward instead of stretching it outward. Its mantle forms a solid cylinder of tissue, firm to the touch, containing muscles arranged in layered bands that contract with quiet authority. These muscles allow it to maneuver with deliberate power, guiding its body through heavy water without wasted effort. The fins at its rear are broad and steady, steering like gentle rudders while the rest of the form remains poised. Even in stillness, there is a sense of contained force, a reserve waiting within the dense mantle walls. Along its arms and tentacles lie structures unlike the smooth cups seen on many of its kin. Each appendage bears swiveling hooks, dark and curved, mounted on flexible bases that allow them to rotate slightly when they meet resistance. When prey brushes against these limbs, the hooks catch and pivot, securing their hold from shifting angles. The mechanism is simple, yet effective, ensuring that contact becomes capture. Between these hooks sit smaller suckers that add further grip, creating a layered system of attachment that works whether the prey struggles or drifts. The waters it calls home are among the coldest inhabited by such large animals, and within that chill, its physiology functions with measured steadiness. Blood carries oxygen through vessels designed to perform efficiently at low temperatures, and enzymes within its cells operate at a pace suited to the frigid environment. This calm internal rhythm matches the outer stillness of its surroundings. Nothing moves quickly here, and nothing needs to. Strength replaces haste, patience replaces pursuit. Though shorter than the long-limbed giant squid, this species outweighs it, holding more tissue within its compact form. Such mass offers advantages. Greater muscle volume provides power when it is needed, and thicker tissues retain warmth generated by exertion. The result is a creature that does not rely on speed or length, but on solidity, a presence shaped for encounters that may be brief yet decisive. Human knowledge of it comes mostly from rare specimens brought up by fishing lines set for other animals, silent visitors from depths seldom seen. In its own domain, it continues its slow passage through Antarctic waters, arms drifting outward, hooks poised, a heavy-bodied figure moving with calm assurance through the cold and shadowed sea. In the polar oceans where winter darkness lingers for long seasons, a quiet shape moves with such restraint that it seems almost suspended rather than swimming. The sleeper shark travels through these cold depths at a pace so gentle that its progress is measured not in distance, but in patience. Its broad body drifts forward with slow strokes of the tail, each motion spaced by long pauses, as though time itself has widened to match its rhythm. This unhurried movement is not a sign of weakness, but of design. In water chilled near freezing, chemical reactions proceed gradually, and muscles contract more slowly. The sleeper shark's physiology reflects this environment. Its tissues function efficiently at low temperatures, its metabolism running at a rate that conserves energy rather than spending it. Oxygen circulates through its blood with steady calm, supporting life that unfolds without haste. Such economy allows it to endure where faster creatures would exhaust themselves. Its eyes often appear clouded, a pale film covering the surface. This haze is caused not by age but by small parasitic crustaceans that attach to the cornea. Even with this dimmed vision, the shark navigates its surroundings using other senses, detecting subtle movements and chemical traces in the water. It does not rely on swift pursuit. Instead, it approaches gradually, guided by signals carried through the currents, until it comes within range of whatever lies ahead. Despite its measured pace, the sleeper shark feeds on substantial fare. Remains of seals and large fish have been found within its stomach, evidence that it can consume prey nearly as large as itself. Some of this food may come from animals already weakened or resting, yet the shark is capable of taking living prey as well. Its jaws close with quiet strength, and once secured, a meal can sustain it for extended periods. In an environment where encounters are rare, the ability to accept large nourishment at once becomes a quiet advantage. These sharks inhabit depths beyond those of many familiar species, descending into waters where cold and pressure settle together. There they continue their slow passage through the dim Arctic Sea, their movements so gradual that observers sometimes describe them as drifting shadows. Growth in such conditions proceeds at an equally patient pace. Studies of certain individuals suggest lifespans that may stretch across centuries, their years accumulating as steadily as layers of ice. So the sleeper shark persists in its silent domain, a creature shaped by cold, depth, and time itself, moving through the dark polar water with the same deliberate calm that has carried its kind across ages. Along certain ridges of the seafloor, the crust of the earth opens in narrow seams, and from these fractures the planet exhales. Columns of dark mineral-rich water rise in slow billowing plumes, towering like underwater chimneys. These formations, often called black smokers, release fluid heated deep beneath the seabed, where it has passed close to molten rock. The temperature of this escaping water can approach that of boiling, yet the immense surrounding pressure keeps it from turning to steam. It pours outward instead, carrying dissolved metals and chemicals that cloud the water in drifting charcoal veils. Around these vents, the seafloor becomes a place of unlikely abundance. No ray of sunlight reaches this depth, yet life gathers here in dense communities. The foundation of this gathering lies not in photosynthesis, but in chemosynthesis, a process through which microscopic organisms draw energy from chemical reactions rather than light. Bacteria cluster along the vent surfaces, forming pale mats and filaments that sway gently in the rising currents. Within their cells, compounds such as hydrogen sulfide are transformed into usable energy, sustaining growth in darkness as reliably as sunlight sustains forests above. Larger creatures settle among these living carpets. Pale crabs move slowly across the mineral crust, their limbs feeling for nourishment. Shrimp hover in clusters, their bodies translucent, drifting close to the warm outflow. Fish circle the chimneys, their motions unhurried, as though respecting the steady rhythm of the vent's release. Many of these animals depend directly on the bacteria, grazing upon them or harboring them within specialized tissues that provide both shelter and nutrients. The partnership allows entire communities to flourish where ordinary food chains could not exist. The environment surrounding a vent is a meeting place of extremes. Just centimeters apart, water temperatures can differ dramatically, one layer near freezing, the next almost scalding. Creatures living here navigate these gradients with precision, positioning themselves where warmth and chemistry balance to their advantage. Their proteins remain stable despite the heat, and their cellular machinery continues its work while minerals swirl past like drifting ash. Over generations, their bodies have adjusted to tolerate conditions that would disrupt most other forms of life. Predators also patrol these oases. Certain fish and crustaceans hunt among the clustered inhabitants, feeding on those drawn by the vent's bounty. They do not rush. They move with measured intent, guided by scent and vibration, selecting moments when prey strays from the shelter of the chimney walls. Even here, where nourishment is more plentiful than in surrounding plains, conservation of effort remains a quiet rule. Thus, the vents stand as steady hearths upon the ocean floor, releasing heat from the planet's interior while sustaining intricate webs of life. Around each dark plume, organisms gather in patient constellations, their existence powered not by distant sunlight but by the earth itself, rising softly through stone and water. Long after the last trace of daylight fades from descending water, existence continues in ways once thought impossible. For much of human history, it was assumed that all life ultimately depended on the sun, that every creature drew its energy from ancient light, transformed through leaves or drifting algae. This belief held steady until explorers lowered instruments into deep ocean valleys and found communities thriving where no ray had ever reached. The discovery, made in 1977 along a remote seafloor ridge, quietly reshaped biology's understanding of what sustains living systems. At the foundation of these hidden ecosystems are microscopic organisms that draw nourishment from chemistry itself. Instead of harvesting light, they obtain energy by oxidizing inorganic compounds released from the Earth's crust. Hydrogen, sulfide, methane, and other minerals become their fuel. Within their cells, molecular reactions unfold with careful precision, converting these substances into usable energy that supports growth and reproduction. The process is known as chemosynthesis, a word that carries the idea of creation through chemistry rather than radiance. These bacteria form the base of entire food webs that exist independently of the surface world. Larger organisms feed upon them directly, grazing along mineral-coated rocks or hosting the microbes within their own tissues. Tube worms, clams, and crustaceans rely on such partnerships, their bodies serving as living shelters where bacterial colonies flourish. In return, the microbes share the nutrients they produce, sustaining their hosts in a quiet exchange that replaces the role of plants in sunlit habitats. Because no sunlight filters down to these depths, there is no day or night, no seasonal bloom tied to the angle of the sun. Instead, the rhythm of life follows the steady release of chemicals from below. As long as these compounds continue to seep upward through cracks in the seafloor, nourishment persists. When the flow slows or ceases, communities gradually diminish, their inhabitants drifting away or fading as resources decline. The entire system is guided not by the sky above, but by processes deep within the planet. The realization that such ecosystems could exist altered scientific thought in lasting ways. It revealed that life does not require sunlight as an absolute condition, only a stable source of energy. This understanding expanded the range of environments considered potentially habitable, not only in Earth's oceans, but on distant worlds where light may never reach the surface. What began as a quiet observation on the ocean floor became a broader insight into the adaptability of living matter. Down in these lightless provinces, bacteria continue their invisible labor, transforming raw chemicals into sustenance, sustaining neighbors that in turn sustain others. The chain extends outward in delicate balance, a self-contained cycle unfolding in darkness, sustained by the planet's own hidden warmth and the patient work of microscopic hands. On the quiet sea floor, where currents slow and sediment settles in soft layers, a pale, armored figure walks with deliberate steps. The giant isopod moves close to the ground, its segmented body arched slightly, each plate overlapping the next like carefully fitted shields. Its many legs touch down in gentle sequence, guiding it across the dark plain with the steady rhythm of something untroubled by urgency. This animal belongs to an ancient lineage of crustaceans, distant relatives of the small pill bugs that wander through garden soil after rain. The resemblance is unmistakable once seen. Both share the same jointed armor, the same tucked head, the same ability to curl slightly when disturbed. In the deep ocean, however, this familiar design has been enlarged to a remarkable scale. Some individuals grow longer than a human forearm, their pale shells reflecting faint hints of surrounding light, their antennae extended forward like careful feelers testing the water. Life here offers little that arrives predictably, so the giant isopod has adopted a metabolism that unfolds with extraordinary patience. Its internal processes proceed slowly, requiring minimal fuel to continue. Because of this restraint, it can endure long stretches without feeding. Observations in controlled environments have shown individuals remaining alive for years without a meal, their bodies sustained by reserves stored during earlier abundance. Rather than searching constantly, it travels in measured paths, guided by chemical traces that drift through the water and settle along the seafloor. When nourishment does appear, it often comes in the form of a rare descent from above. The body of a fallen whale, after its long journey downward, becomes a sudden oasis of sustenance. Such arrivals draw scavengers from across the surrounding plain, and among them, the giant isopod approaches with steady persistence. Its mouth parts, small yet efficient, rasp gently at the soft tissues, removing fragments that provide energy enough to last for extended spans. It does not hurry, for there is no need. The feast may remain for months, sometimes longer, slowly diminishing as each visitor takes its share. Its eyes, dark and reflective, are adapted to the dim environment, able to detect faint contrasts against the sediment. The antennae serve as sensitive guides, registering subtle chemical gradients that reveal distant sources of food. Together, these senses allow it to navigate a landscape where visual landmarks are few and distances stretch wide. So it continues its quiet patrol across the ocean floor, armored body gliding over silt, limbs lifting and placing with calm precision. In a world where scarcity shapes every life, the giant isopod endures, through patience, its ancient form unchanged in essence, carrying forward a design that has long understood how to wait. Far above the silent plains of the abyss, a final descent sometimes begins without witness. When a great whale's life ends near the surface, its body slowly starts to sink, drawn downward through layers of water that grow colder and heavier with depth. The journey can last many hours, even days, as the immense form settles through the column, accompanied only by drifting particles and the faint currents that slide past its skin. Eventually, it reaches the seafloor and comes to rest upon the sediment, a vast shape lying still where few large bodies ever arrive. In that quiet landing, an unexpected transformation begins. The arrival of such a mass introduces a sudden abundance into a place where food usually appears only in scattered traces. Scent spreads outward through the water, carried along invisible pathways. Creatures that roam the surrounding expanse detect the signal and change course. Fish, crustaceans, and other scavengers gather, approaching with measured movements until they reach the fallen giant. They begin to feed, removing soft tissue in careful bites, their numbers gradually increasing as the message continues to travel. This first stage may last for months, sometimes longer, as larger visitors take their share. When most of the flesh is gone, a second community settles in. Smaller organisms arrive to consume what remains within the bones and along their surfaces. Worms and mollusks burrow into crevices, extracting nourishment from fats and proteins locked inside the skeleton. Bacteria multiply across every exposed surface, breaking down material at a microscopic scale, releasing chemicals that sustain still other forms of life. The carcass becomes less a single body than a living landscape, supporting layers of inhabitants that change as time passes. Years may slip by in this gradual conversion. The bones soften as their contents are slowly dissolved. Sediment gathers around them, and new species take the place of those that came before. Some of these organisms exist almost nowhere else, adapted specifically to the conditions created by such remains. Even after the structure itself begins to fragment, the surrounding seafloor can remain enriched, sustaining animals that continue to graze upon the lingering nutrients. The entire process can extend across decades, each phase blending into the next without clear boundary. What began as one creature becomes a sequence of habitats, each supporting its own inhabitants, each fading gently into another. In this way, a whale's descent does not end with stillness. It becomes a long unfolding, a quiet offering that nourishes countless lives far below the waves, where the seafloor receives it and, over many years, slowly returns it to the wider sea. At the far western edge of the Pacific, the seafloor bends downward into a vast crescent-shaped hollow where the crust descends farther than anywhere else on Earth. This is the Mariana Trench, a place where depth becomes almost abstract, where distance is measured not across the surface, but straight down through water layered mile upon mile. Its deepest known point, called Challenger Deep, lies nearly 11,000 meters below the waves, a vertical reach so great that if the tallest mountains were placed within it, their peaks would remain submerged. The descent into this trench passes through zones that grow steadily more still. Currents weaken, temperatures hover just above freezing, and the weight of the ocean gathers until it presses with a force difficult to imagine. Only a handful of human journeys have ever reached this floor. Submersibles built with thick walls and carefully sealed joints have made the voyage, carrying observers into the silence for brief visits before rising again toward lighter waters. Each descent requires meticulous preparation, for the conditions allow little margin for error. Instruments must endure pressures strong enough to compress most materials, and light must be brought along, since none exists naturally at that depth. Yet even here, life continues. Along the sedimented bottom, small creatures move through the fine silt, leaving delicate trails that soon settle closed behind them. Amphipods, translucent and many-legged, wander across the surface, feeding on particles that drift down from distant layers above. Their bodies contain compounds that help stabilize their cells, allowing them to function where pressure would disrupt ordinary tissues. Nearby, slender snailfish glide just above the seabed, their forms soft and lightly built. Instead of rigid skeletons, they rely on flexible structures that yield gently to the surrounding force, maintaining their shape without fracture. These animals live quietly, their movements unhurried, their existence shaped by conditions that change little from one year to the next. Food arrives in small amounts, settling like faint dust. There are no sudden storms, no shifting seasons of warmth or cold, only a steady environment that persists with remarkable constancy. In such stillness, Survival depends on subtle adaptations rather than speed or strength. The trench itself stretches for thousands of kilometers, a narrow valley carved into the planet's outer shell. Its slopes rise steeply on either side, guiding sediments downward until they gather in the deepest basin. There, at Challenger Deep, the seafloor rests under a column of water heavier than any other on Earth. Despite that immense burden, fragile lives continue their gentle routines, moving through the fine grains, feeding, growing, and enduring in a place where the world above feels unimaginably distant. Records of depth are usually kept for mountains and aircraft, yet the ocean holds its own quiet extremes. In one of its deepest basins, where the seafloor rests beneath nearly 11,000 meters of water, a small fish has been observed living calmly against that immense weight. This animal, known as the Mariana snailfish, occupies a range so far below ordinary limits that most vertebrates cannot function there at all. It exists not as a visitor, but as a resident, shaped by generations that have known nothing else. Its form appears almost delicate, composed of soft tissues that seem closer to gelatin than muscle. The body lacks heavy bone and firm scales, relying instead on flexible material that yields gently to the surrounding force. This softness is not fragility, but adaptation. In an environment where pressure presses from every direction, rigid structures would risk fracture, while pliant ones maintain their integrity by allowing slight compression. The snailfish's shape reflects this principle, its outline smooth and rounded, its movements slow and controlled. Inside its cells, chemistry follows similar logic. Molecules that stabilize proteins circulate within its fluids, helping delicate structures retain their shape despite the crushing conditions. These compounds allow enzymes to continue their work and membranes to remain functional. Without them, the machinery of life would falter. With them, biological processes unfold as steadily as they would in far gentler places. The fish's blood and tissues maintain balance with the surrounding pressure, so there is no violent contrast between interior and exterior. The animal drifts just above the seabed, guiding itself with small fins that ripple like thin fabric. Its eyes are modest, suited to faint contrasts rather than detail, and its mouth opens to gather tiny invertebrates that live among the sediments. Food is sparse, yet its slow metabolism requires little. Each movement is measured, each adjustment subtle, conserving energy while it glides through water heavier than any other inhabited by fish. Most sharks never descend anywhere near this realm. Their bodies, built for different conditions, would struggle to function under such force. The snailfish, by contrast, has no need to resist. It belongs here as naturally as shallow species belong to reefs or shorelines. What would overwhelm others simply surrounds it, accepted without strain. Observations of this species have come from specialized cameras lowered carefully into the depths, their lights revealing brief glimpses before ascending again. In those moments, the fish appears serene, suspended above the sediment like a drifting petal. It does not hurry away. It continues its gentle passage, a small living presence in the deepest known habitat of its kind, where life persists in quiet harmony with the weight of the sea. Far beneath the surface, where light no longer shapes perception, another sense begins to dominate the vastness. The ocean carries sound with remarkable devotion, guiding vibrations across distances that would seem impossible in air. Water, dense and continuous, allows these waves to travel with little loss, and in certain layers the conditions align so precisely that sound becomes almost tireless in its journey. Within one such layer lies a phenomenon known as the SOFAR channel, a natural corridor where pressure and temperature combine to form a path of minimal resistance. In this acoustic passage, tones released at one point can move outward for thousands of miles, bending gently with the curvature of the earth, remaining clear long after they would have faded elsewhere. The channel forms because sound waves refract toward regions where their speed slows. Above and below this layer, variations in temperature and pressure redirect the waves back toward its center, keeping them contained. Once inside, a vibration can travel astonishing distances, its energy preserved by the surrounding gradients. A call uttered by a distant whale or the rumble of shifting seafloor may cross entire ocean basins, arriving faint yet recognizable far away. For animals living in darkness, such transmission offers a form of awareness that vision cannot provide. Low-frequency sounds pass easily through the water, revealing movement, size, and direction. Many species produce calls that carry across this channel, their voices shaped by evolution to suit its properties. The ocean becomes threaded with signals that overlap and drift, a quiet tapestry of resonance connecting distant lives. Human instruments lowered into these depths have occasionally recorded noises that once seemed mysterious, tones and pulses with no obvious source. Early listeners described them as distant knocks, metallic hums, or drawn-out echoes. With time and careful study, many of these sounds were traced back to living origins. Some belong to whales, whose voices stretched across hundreds of kilometers. Others came from fish, crustaceans, or the subtle friction of organisms moving along the seafloor. What first appeared unfamiliar gradually resolved into a language already spoken throughout the water. The Sofar channel itself shifts slightly with changing conditions, rising or sinking as currents alter temperature layers. Yet it persists as a steady pathway, a hidden avenue through which vibrations glide. Within it, sound does not hurry. It travels with patient continuity, crossing unseen distances, carrying news of movement and presence from one far horizon to another. So, in the deep ocean, silence is never complete. Beneath the stillness, waves of sound wander endlessly, touching creatures separated by vast expanses, weaving connections through the water that no eye could follow, yet every listening body can sense. Stillness can become a posture rather than an absence of motion, and on certain stretches of the deep sea floor, a small fish has made that posture its way of life. The tripod fish rests above the sediment not by swimming and not by sinking, but by standing. 3 elongated fin rays extend from its body like slender stilts, touching the ground and holding it in place. Balanced upon these delicate supports, it remains poised in the water, neither drifting nor settling, suspended as though gently anchored to the earth below. The fins that form this living tripod are thin yet resilient, strengthened by flexible rays that resist bending even under the surrounding pressure. 2 extend downward from the pelvic region, while a third reaches from the tail, creating a stable, triangular base. With these supports planted, the fish can maintain its position without expending energy to hover. Its body tilts slightly upward, angled into the faint current that slides across the seabed. In this orientation, it becomes part of the flow rather than separate from it. Its eyes are small and its coloration subdued, features suited to a realm where vision plays a lesser role. Instead, it relies on touch and vibration. Long fin filaments spread outward into the water, acting like delicate antennae that register subtle disturbances. When drifting organisms brush against these extensions, the signals travel instantly along the sensitive rays. The fish responds with a smooth motion of its jaws, capturing whatever the current has delivered. There is no chase, no sudden dart. Food arrives on the moving water, and the fish receives it with quiet precision. This method of feeding allows it to conserve strength in a landscape where energy must be used sparingly. Muscles remain relaxed, the heart beats slowly, and respiration proceeds at an unhurried pace. The fish may hold its position for extended periods, adjusting only slightly when the direction of the current shifts. Should the flow change significantly, it lifts its slender supports, drifts a short distance, and settles again, replanting its rays in a new patch of sediment. Around it, the seafloor stretches in wide plains, interrupted only by gentle ripples of silt. The tripod fish becomes part of this still tableau, its form blending with the quiet geometry of the bottom. Passing creatures may scarcely notice it until they drift close enough to brush against its waiting filaments. In that instant, the boundary between environment and animal seems to dissolve, as though the fish were simply another extension of the landscape. So it remains there, balanced lightly upon its narrow stilts, facing the slow current, patient and composed, a small sentinel of the deep, whose survival depends not on motion, but on the art of remaining almost perfectly still. Time sometimes leaves behind living fragments of its earlier chapters, shapes that seem to have slipped quietly past the turning of ages. The frilled shark carries such a presence within its form, moving through deep water with a silhouette that recalls distant eras rather than modern seas. Its body is long and supple, more reminiscent of an eel than of the familiar triangular outlines often associated with sharks. The spine bends in smooth curves, and the tail tapers gently, giving the entire animal a flowing profile that appears almost serpentine as it glides. Along the sides of its throat lie folds of skin that form soft fringes, the structures that give this species its name. These frills ripple faintly as water passes over them, delicate features that contrast with the formidable equipment hidden inside its mouth. When the jaws part, they reveal rows of slender teeth numbering close to 300, each one narrow and sharply pointed. Arranged in layered arcs, they angle backward toward the throat, creating a dense lattice that allows prey to slide inward, yet offers little chance of retreat. The teeth are not broad or crushing. Instead, they function like fine needles, designed to grip with certainty once contact is made. The head remains relatively small compared with the length of the body, and the eyes are dark and steady, suited to faint illumination. Most of the time, the shark moves with measured calm, its motions unhurried as it navigates through its shadowed surroundings. Muscles beneath the skin are arranged for flexibility rather than speed, enabling the animal to curve and coil with fluid control. Observers who have encountered it suggest that when the moment arrives, it may strike not with a long chase, but with a sudden extension, the body straightening swiftly from a curved posture. This motion resembles the release of a tightened spring, brief and precise, bringing the jaws forward before stillness returns. Its anatomy hints at ancestry that stretches far back through geological history. Fossil relatives bearing similar shapes appear in ancient rock layers, indicating that this general design has persisted with little alteration for immense spans of time. Such continuity suggests a form already well suited to its environment, one that required no dramatic revision as oceans changed around it. While many lineages shifted and diversified, this one remained close to its original pattern, carrying forward a blueprint refined long ago. Encounters with living individuals are uncommon, since the species spends much of its life in deeper waters beyond ordinary reach. When it is seen, its appearance often feels less like a discovery than a brief meeting with something remembered from an older world. The elongated figure drifts, teeth concealed once more behind closed jaws, its ancient outline passing quietly through the dim sea as it has done for ages beyond counting. Distance in the deep ocean is not measured only in space but in encounter. Individuals may drift for long stretches without crossing paths with another of their kind, separated by wide volumes of water that hold few travelers. In such solitude, populations remain sparse, scattered across vast territories where chance meetings are rare events. Life continues, yet it unfolds in a quieter register, shaped by absence as much as by presence. Because neighbors are few, reproduction follows a slower rhythm. Many deep-dwelling species mature gradually, taking years before they are ready to produce offspring. When that time arrives, they often release only small numbers of young, investing carefully in each one rather than scattering thousands. Some rely on brief alignments of season or current, subtle cues that bring individuals together just long enough for new life to begin. Others carry their developing young within or upon their bodies, protecting them until they are capable of surviving alone. In every case, the pace remains deliberate, guided by the reality that opportunities to reproduce may come only rarely. Isolation also shapes the direction of change across generations. In environments where conditions remain stable for long periods, natural selection can refine traits with remarkable precision. A feature that offers even slight advantage may persist and become more pronounced, while unnecessary structures gradually diminish. Over time, this process leads to forms that seem almost tailored to a single way of living. Eyes may shrink if vision offers little benefit. Fins may lengthen if they improve balance in gentle currents. Organs may adjust their chemistry to suit constant cold or pressure. Each adaptation narrows the range of conditions an organism can tolerate, yet within its chosen niche, it becomes exquisitely suited. Such specialization carries both strength and vulnerability. A creature perfectly adapted to one environment may find it difficult to survive elsewhere, yet as long as its home remains unchanged, it can persist with quiet success. In the deep ocean, where temperatures shift slowly and landscapes alter only over immense spans of time, these refined designs can endure for ages. Generations follow one another with subtle variation, each inheriting the traits that proved effective before. The result is a community composed of individuals shaped not by competition in crowded waters, but by long intervals of solitude. Their bodies tell stories of patience, their life cycles echoing the steady pace of their surroundings. They do not rush to grow or multiply. Instead, they exist in balance with their environment, changing gradually, almost imperceptibly, as centuries pass. So evolution in these remote depths proceeds like a quiet current, moving steadily yet without haste, guiding forms toward ever finer harmony with the conditions that cradle them, until each species becomes a precise expression of the place it calls home. Maps of the ocean floor often appear complete at first glance, their shaded contours suggesting familiarity, yet most of those shapes are only approximations drawn from distant measurements. Beneath the surface lies a terrain more extensive than all the continents combined, and much of it remains known only in outline. Wide plains, ridges, and valleys stretch across the planet's submerged crust, but large portions have never been observed directly. The seafloor, though part of Earth's own body, is still largely unseen. The difficulty arises from distance and environment. Light cannot reach most of these regions, and pressure builds steadily with depth, placing limits on how long instruments can remain and how clearly they can record. For many years, exploration relied on weighted lines and echo sounding, methods that revealed depth but not detail. Only recently have technologies grown capable of approaching the seabed closely while transmitting images and measurements back to the surface. Among these tools are remotely operated vehicles, mechanical explorers guided from ships above by long cables that carry power and information. Their cameras peer into darkness, their articulated arms collect samples, and their sensors record conditions that human bodies could not endure unaided. Each descent of such a vehicle reveals landscapes that seem untouched, slopes of sediment marked only by faint tracks, outcrops of rock where unfamiliar forms cling or drift. Often, the first glance is also the first time any eye has witnessed that place. Within these visits, new species are encountered with quiet regularity. Scientists describe animals whose shapes and behaviors have never been documented, adding them to catalogs that continue to expand year after year. Some are small and delicate, others unusual in form or color, yet all share the distinction of having lived unseen until that moment. The rate of discovery suggests how much remains hidden. Estimates indicate that only a small fraction of the deep seabed has been mapped in high resolution, leaving vast stretches known only through rough surveys. Even where outlines exist, the details of life upon those surfaces often remain unrecorded. Currents shift sediments, organisms move or grow, and entire communities thrive beyond observation. The ocean preserves these secrets not through intention but through scale, its immensity allowing countless habitats to persist without notice. Exploration continues slowly, each expedition adding another fragment of understanding. Data returns to the surface in streams of numbers and images, and from these fragments, scientists assemble clearer pictures of the underwater world. Yet with every new detail revealed, the extent of what remains unknown becomes more apparent, stretching outward beyond the reach of current journeys. So the deep ocean endures as a frontier close to home yet still largely unexplored, its wide floors and hidden inhabitants waiting in patient obscurity, holding within their depths a vastness that invites discovery while quietly remaining itself. Not all boundaries in the ocean are visible. Some exist as gradual thresholds where conditions shift so subtly that only living bodies perceive them. For many sharks, such thresholds mark the lower edges of their world, quiet lines beneath which their physiology begins to struggle. These animals are shaped for certain ranges of temperature, chemistry, and motion, and as depth increases, those ranges begin to slip away from what their systems can comfortably endure. Water grows colder with descent, often approaching temperatures only a few degrees above freezing. Most sharks depend on metabolic reactions that function best within a moderate thermal window. Their muscles, nerves, and digestion rely on chemical processes whose speed changes with temperature. As the surrounding water chills, these reactions slow, movement becomes less efficient, and the energy gained from food may no longer balance the energy required to hunt or swim. Some species possess adaptations that help conserve warmth, yet these mechanisms have limits, and beyond them the cold imposes a quiet restraint. Oxygen availability also shifts with depth. In many deep regions, dissolved oxygen becomes scarce, leaving less of it available for extraction through gills. Sharks typically require a steady flow of oxygen to sustain their active lifestyles. Their bodies are designed for continuous motion, with gill structures that function most effectively when water passes over them in a constant stream. In low oxygen layers, that supply diminishes, and the balance between intake and need grows more delicate. Organisms that thrive there often have slower metabolisms or specialized respiratory pigments, traits that most sharks do not possess. Energy itself becomes a central consideration. Hunting in deeper zones often demands patience rather than pursuit, and prey may be encountered only rarely. Sharks are generally built for sustained swimming, and swift bursts of speed, abilities supported by strong muscles and streamlined forms. Maintaining such equipment requires fuel. In regions where meals are infrequent, the cost of carrying that muscular structure may exceed the benefit it provides. Over evolutionary time, this trade-off encourages many shark lineages to remain in layers where food is more reliably found and movement can be supported without strain. Structure plays its part as well. The skeletons of sharks are composed of cartilage, flexible and resilient, yet their bodies still contain spaces and tissues that respond to pressure in ways suited to shallower conditions. Species that inhabit extreme depths often show different proportions, reduced mineralization, or biochemical adjustments that stabilize their cells. Most sharks lack these modifications, and so their forms reflect environments closer to the surface than to the abyss. A few species venture deeper than others, carrying partial solutions to these challenges, yet the majority remain within ranges that match their design. Their absence from the lowest realms is not a limitation of courage or instinct, but a quiet alignment between body and world. Each species occupies the layer where its physiology moves in harmony with the surrounding sea, and below that gentle boundary, other forms continue the story. Fear, in the deep ocean, does not arrive as a sudden movement or a visible threat. It emerges instead as a quality of the environment itself, something woven into the water long before any creature appears. Down here, danger rarely announces its presence. It lingers quietly, indistinguishable from the surrounding dark, until the moment it acts. The sensation is not one of pursuit or collision, but of waiting, as though the sea itself were holding its breath. Many animals of these depths do not rely on force or swiftness. Their bodies are not shaped for long chases or violent struggles. Rather, they are built for stillness, for endurance, for the ability to remain unnoticed while time passes. A predator may hover without motion for hours, conserving energy, letting currents drift past its fins while it watches with senses attuned to the faintest disturbance. Muscles remain relaxed, hearts beat slowly, and every movement is measured. In such conditions, patience becomes a strategy more powerful than speed. Silence deepens this effect. Without waves breaking above or winds stirring the surface, sound diminishes to soft vibrations that travel slowly through the water. Creatures sense these subtle signals through sensitive organs that register pressure and motion. A distant flutter of fins, a slight displacement of water, or the gentle rhythm of another animal's breathing can be enough to reveal its location. The hunter does not rush. It waits for proximity to do the work that pursuit would require elsewhere. The absence of light completes this quiet transformation. Without illumination, outlines dissolve and colors fade into uniform shadow. Vision, when it exists, often detects only contrast or glow, never detail. In such conditions, appearance loses importance, and presence becomes something felt rather than seen. A body can drift within arm's length and remain invisible until it chooses to move. Darkness becomes a veil that favors restraint, rewarding those who merge with it rather than those who disturb it. This atmosphere shapes behavior across entire communities. Movements grow slower, gestures smaller, interactions more deliberate. Even creatures that might seem formidable in another setting become part of a subdued rhythm, their actions softened by the surrounding stillness. Nothing needs to hurry, because the environment itself encourages calm persistence over sudden effort. So the character of unease in these waters does not resemble the sharp tension of a chase. It resembles quiet expectancy, a sense that something may be nearby without ever revealing itself. Here, the unknown is not a distant possibility but a constant companion, resting within the dark alongside every drifting life. From orbit, Earth reveals its proportions without explanation. Blue spreads across most of the visible sphere, continents appearing as scattered shapes within a vast, continuous expanse. That blue is not a surface detail, but the dominant feature of the planet, for water covers more than 70% of its exterior. Beneath that broad covering lies the largest habitat our world possesses, extending downward through layers that together contain far more living space than all land environments combined. Most of this realm exists far below the reach of coastal shallows or sunlit waters. The deeper regions form an immense interior, a hidden volume that surpasses the combined capacity of forests, plains, and skies. Within it, countless organisms occupy niches stacked one above another, each layer holding its own residence, movements, and exchanges. The result is not a single environment, but a vertical landscape of habitats, arranged like stories in a towering structure whose base rests along the ocean floor. For a long time, such depths were assumed to be nearly empty, places where life could not persist. Early naturalists believed that darkness, pressure, and cold would exclude most organisms, leaving only barren expanses. Yet careful exploration gradually revealed the opposite. Wherever instruments descended, signs of life appeared. Creatures moved through the water column, others rested upon sediments, and still others clung to rocky surfaces. Some were delicate, some resilient, some so unfamiliar in form that they seemed almost imagined. Together, they demonstrated that living systems can adapt to conditions once thought inhospitable. What allows this abundance is the flexibility of biology itself. Cells adjust their chemistry to function under strain, membranes alter their composition to remain stable, and metabolic pathways shift to use whatever resources are available. Over generations, these adjustments become inherited traits, enabling populations to flourish in places that would challenge unadapted organisms. The deep ocean thus becomes not a marginal zone, but a vast domain shaped by specialization and persistence. Currents move nutrients through these waters, linking distant regions in slow circulation. Particles descend from above, minerals rise from below, and between them organisms feed, grow, and reproduce. Even in areas where resources arrive only occasionally, communities establish themselves, balanced carefully with what their surroundings provide. Life here does not rely on abundance. It relies on efficiency, patience, and the ability to endure. Seen as a whole, this underwater world forms the largest continuous living space on the planet, a realm whose scale surpasses ordinary perception. It stretches beneath every ocean basin, surrounding continents, connecting poles to equator in an unbroken network of habitats. Within that immense volume, existence continues quietly, demonstrating that life is not confined to gentle settings, but can take hold wherever conditions allow it, filling the planet's greatest domain with forms both subtle and extraordinary. Above, the upper waters form only a narrow band, a slender envelope where brightness and motion meet. Within that limited span, many familiar ocean animals live their entire lives, moving through currents warmed by sunlight and stirred by winds. Sharks, with their strong bodies and restless swimming, belong largely to this elevated realm, a region defined not by height but by proximity to the surface. It is a world shaped by light, by shifting temperatures, by the steady exchange between sea and sky. Below that narrow margin, conditions change in quiet succession. Each descending layer carries its own balance of forces, its own pace, its own unwritten laws. The deeper zones do not simply continue the surface environment, they transform it. Temperature settles into cold stability, pressure increases with steady persistence, and nourishment becomes something to be discovered rather than expected. Life that endures here does so by following rules different from those that guide swift hunters above. Strength gives way to efficiency, motion yields to restraint. Survival favors forms that match their surroundings with careful precision. Over immense spans of time, evolution has shaped inhabitants suited to these depths. Bodies soften where flexibility is safer than rigidity. Metabolisms slow until each movement is measured against the cost it requires. Senses adapt to detect faint signals that travel through darkness and water. What might seem unusual elsewhere becomes entirely appropriate here, each trait reflecting generations of gradual adjustment. These organisms do not struggle against their environment. They align with it, as though molded by the very conditions that surround them. Seen in its full vertical extent, the ocean resembles a planet turned on its side, its habitats stacked rather than spread. Instead of continents and skies, there are layers descending one beneath another, each with distinct residents and rhythms. Creatures of the upper band rarely cross into the deeper ones, just as deep-dwelling species seldom rise toward the brightness above. Boundaries exist not as walls, but as transitions, subtle thresholds where one way of living fades and another begins. Our journey downward has followed this layered world from its familiar heights into its quietest reaches. The descent has revealed forms adapted to pressure, darkness, and scarcity, each one part of a vast continuum extending far below ordinary sight. Even as that descent comes to rest, the lowest expanses remain, stretching outward in stillness beyond where observation has traveled. There, in the immense depths that persist beneath all known paths, the abyss continues in its calm and patient existence.